Good morning, students. Dear students, as in the previous video, we had discussed about free body diagram and we had also discussed the applications in which we had discussed the various type of forces which are used in mechanics. In that we had discussed about buoyant forces, tension in the string, spring force, gravitational force, contact forces, non-contact forces, and we had discussed that when a body is in equilibrium, then how can we draw the free body diagram of that body to know or to calculate about the forces which are acting on that body to make the body in equilibrium. Now, today we are going to discuss some good numericals based on free body diagram and equilibrium of forces. So, one of the numerical is in front of you. So, look at here, students. Here it is given that a wooden block of mass 2 kg rests on soft horizontal floor. This is a soft horizontal floor and a wooden block of mass 2 kg. This is a wooden block of mass 2 kg is rests on this soft horizontal floor. When an iron cylinder of mass 25 kg is placed on the block. Now, after that, an iron block of mass 25 kg is placed over this block of mass 2 kg. The floor yields steadily. What does it mean? The floor yields steadily means after putting a mass of 25 kg over this 2 kg block, the whole system, that is 25 kg plus 2 kg starts moving downward. The block and the cylinder together go down with an acceleration of 0.1 meter per second square. 0.1 meter per second with an acceleration of 0.1 meter per second square. That 25 kg iron cylinder and 2 kg block goes downward. What is the action of the block on the floor? First of all, you have to calculate the action of the block on the floor. Before and after the flow rates. Before the flow rate means when the 25 kg of mass is not placed over the 2 kg block. At that time, you have to calculate the action of the block on the floor. And when 25 kg block is placed over 2 kg block, then also we have to calculate the action of the whole system, that is 25 kg plus 2 kg on the floor. Here G is taken as 10 meter per second square. So look at the solution. First of all, we will write the data which is given. So mass of the block it is given. Mass of the block, mass of the block which is equal to mass of the block which is equal to 2 kg it is given. Mass of the cylinder, mass of the cylinder, that is equal to 25 kg. It is given in the question. And then acceleration due to gravity, acceleration of the system, acceleration of block plus cylinder. This is the block cylinder system and its acceleration is given that 0.1 meter per second square, and acceleration due to gravity g is given in the question. G is equal to 10 meter per second square. All these things it is mentioned and given in the question. So first of all, we have to calculate the action of the block when iron cylinder is not kept over the block. So, dear students, we have to calculate the action of the block. So, initially we have to find out, that is 2 kg block is kept over here, and there is no any mass or idle cylinder is kept over the 2 kg block. So here, drawing free body diagram for the 2 kg block, drawing free body diagram. So you will get, that is 2 into mg. So mg means 2 into g, and there is the normal reaction by Newton's third law. And initially there is no any acceleration. Initially there is no any acceleration. So we can write it as weight is equal to m into z, and it is equal to 2 into 10 kg meter per second square, and it is equal to 20 Newton. It is equal to, weight is equal to 20 Newton, and net force on the block is 0. Net force on the block, net force on the block is 0. Since net force on the block is 0, then R is equal to mc, and it is equal to R is equal to 20 Newton. Means initially the normal reaction is what? Initially the normal reaction is 20 Newton. Now after that what we have done? We have kept a block of 25 kg over 2 kg. After putting a block of 25 kg over, after putting a block of 25 kg over 2 kg. So look at the system. Here there is 2 kg block, and over this an iron cylinder of 25 kg, is kept over the block of mass 2 kg, and then the system yields steadily with 0.1 meter per second square acceleration, 0.1 meter per second square acceleration. Now drawing the free body diagram for the given system. So here the masses, both the masses combined together is 25 plus 2, that is 27. So if you consider a mass of 27 into z and acceleration 0.1 meter per second square, then normal reaction becomes R dash. That normal reaction becomes R dash. So we have to calculate the normal reaction R dash, and it is equal to, the weight is equal to, W is equal to m into z, that is equal to 2 27 into 10 kg meter per second square, and it is equal to 270. It is equal to 270 Newton. Now W minus R dash, since the look at here students, since this system is moving downward, this system is moving downward, so here we will do what? We will and the acceleration is in the downward direction, so on calculating the net force acting on the system, what we will do? We will subtract the normal reaction from the weight, that is W minus R dash is equal to M into A. W minus R dash is equal to M into A. And from here we can calculate. Weight we have calculated 270 Newton minus R dash is equal to 27 into 0.1. 27 into 0.1. I think it is clear to you students. Now I am having this one. You can write it as mass as, if it is not clear to you, then you can write it as 25 plus 2 kg into 0.1 meter per second square. And now you can write it as 270 minus 27 into 0.1 is equal to R dash 270, and it is equal to 270 minus 2.7 is equal to R dash. So on subtracting 270 minus 267.3 Newton. So the value of normal reaction R dash 267.3 Newton. R dash is equal to 267.3 Newton. So we have calculated both the action reaction pair in both the cases when there is no mass kept over the no idle cylinder is kept over the block of mass 2 kg, and here we have calculated when a 25 kg mass is kept over the block of mass 2 kg, then net mass is equal to 25 plus 2, that is 27 kg, and after that we have drawn the free body diagram, and then since it is moving downward, so we have calculated the net force for equilibrium condition W minus R dash is equal to Ma, and from here we have calculated the normal reaction in this case, and in this case the normal reaction will be 220 Newton, and in this case the normal reaction 267.3 Newton. So this is the first numerical. Now we are coming to the next numerical, students. So dear students, here look at the next problem, that is numerical 2, and in this numerical it is given that there are two masses M1 and M2. There are two masses M1 and M2, and they are connected by a light inextendable string. This is a light inextendable string. What is the meaning of saying light and inextensible? Means the length of the string with which the masses have been attached is not going to be varied, and since it is light, it means the mass of the string is not going to be considered here. Passing over a smooth light pulley means the mass of pulley is not being considered for our calculation purpose, which which is fixed on a rigid cord. This is a cord and a rigid support is there. In rigid support it is fixed. As shown in figure, find the tension in the rope. You have to find the tension T produced in the rope and the acceleration of each block. You have to find the value of T and you have to find the value of acceleration A. So you have to find the value T, that is tension produced in the string, and the tension produced in the string and the acceleration. So for this we have to draw the free body diagram. To solve this problem, we have to draw the free body diagram for each and every component of this system. This system is called as a Toots machine. A Toots machine is, this system is known as a Toots machine. And for this, we will draw the free body diagram for M1, M2 and for the pulley. And now, after drawing the free body diagram, we will calculate the equation and we will write the equation and then calculate the equations to get the value of acceleration A and tension produced in the string T. So let us start. I am rubbing it. Dear students, look at here. Draw free body diagram. Free body diagram for each part of the system. We have to draw the free body diagram for each part of the system, and we have to assume that, assuming M2 is greater than mass M2 of this system is greater than M1, so M2 will move downward and M1 moves upward. So F.B.D. free body diagram or dynamics of mass M1. Free body diagram or dynamics of mass M1. So look at here, student, for M1 I am drawing. So for M1, weight here M1 into G and then tension T. The force, look at here, students. M1G is the weight, tension T. Since it is the earth is pulling it downward, so due to that, a tension T is produced in the string. With that string with which the pulley is attached, and since it is accelerating upward, so a force M1 into A is experienced in upward direction. So writing the equation from this free body diagram, what we can write? We can write it as T minus M1G is equal to M1A. Mark it as equation 1. This is the free body diagram for mass M1. Now mass M1. Now free body diagram. Free body diagram for mass, free body diagram for mass M2, and we have to draw the free body diagram for mass M2. This is mass. This is mass M2. This is mass M2. So its weight in downward direction, that is M2 into Z, M2 into Z, and it is accelerating in downward direction, that is M2A, and the normal reaction by Newton's third law, it is T. Now here, since it is moving in the upward direction, so we have written it as T minus M1G is equal to M1A. Now look at here, students, it is moving in downward direction, so the equation will be M2Z minus T is equal to M2A. Right, it is equation number 2. So for mass M1, mass M2, we have drawn the free body diagram, and then free body diagram for pulley. Free body diagram for pulley. For this pulley, we have to draw the free body diagram. Look at here. If we draw the free body diagram for this pulley, then its normal reaction R and tension T. So we can write it as, since no external force is acting, since there A is equal to 0 here, there is no acceleration in the pulley, so we can write it as R minus 2T is equal to 0, or we can write it as R is equal to 2T. So mark it as equation number 3. This is equation number 3, this is equation 2, equation 1. So here we have drawn the free body diagram on the 3 cases. Now adding equation 1 and equation 2. Now this is the free body diagram, this is the free body diagram, this is free body diagram for mass M1, this is free body diagram for mass M2, and this is the free body diagram for the pulley. Now we have to solve these 3 equations, all these 3 equations for the calculation of acceleration and tension produced in the string. Look at here, student, no need to be confused here. Here M1 is acting downwards, so tension is appearing here. Now, so we had calculated it as M2 in downward direction and tension is here. But in case of pulley, this is the pulley. So when we are drawing the free body diagram for the separate pulley, then the ropes are attached here. Ropes are attached here. So there is a normal reaction in upward direction due to the tensions produced, due to the tension weight of the string. In this we have to consider the weight of the string, and for that we have to treat the tensions are acting in downward direction and normal reaction is upward direction. If we are drawing the free body diagram for the pulley, then there is no need to consider whatever the forces acting due to mass M1 and M2. We have to treat the pulley as a separate. Clear, student? So we have here to consider the tensions in downward direction and normal reaction in upward direction. Now solving the equations, adding equation 1 and 2. Adding equation 1 and 2. On adding equation 1 and 2, what we will get? T minus M1G. T minus M1G is equal to 0. This is our is equal to M1A. And M2G minus T is equal to M2A. Now if you are going to add these equations, then T to T cancel out and you will get M2 you will get m2 minus m1 into z is equal to m1 plus m2 into a, and from here you will get a is equal to m2 minus m1 into z upon m1 plus m. This the value of acceleration you had got. The value of acceleration you had got. Now substituting, suppose this is equation number 4. This is equation number 4. Substituting this equation 4 either in equation 1 or equation 2. So either in equation 1 or equation 2. Putting these values in equation 1. I am writing, students, there is no need of this diagram. Now we have resolved and drawn all the free body diagrams, so I am writing it here also. Now putting this equation, this value in equation 1 to find out the tension T. The tension T is equal to m1 a plus m2 g. Now putting this value a here, m1 m2 minus m1 into g upon m1 plus m2 plus m2 g. Clear, students? m2 minus m1 g upon m1 plus m2 g plus m2 g. Now taking m1g, oh sorry, this is the problem. It is m1g. Now because here m1g, so it will be m1g. Now taking m1g outside, m1g, taking m1g common, and it will become m2 minus m1 upon m1 plus m2 plus 1. And here look here, students, m1g. Now m2 minus m1 plus m1 plus m2 upon m1 plus m2, and from here m1 to m1 cancel out, and t is equal to 2 m1 m2g upon m1 plus m. This is the tension. This is the tension we have calculated. So the values are not given for m1 and m2. This is the general expression. So acceleration, for this problem you can directly memorize these values also. If such type of problem with data is given in the examination, suppose in various examinations, if it is given that suppose this is a pulley and this is a pulley, mass pulley system, and it is given, and here it is given that 2 kg, and here it is given that 5 kg, and then it is asked the question, find the tension produced in the string and what is the acceleration. So acceleration of the block, so mass 2 kg and 5 kg, then in that case you can directly put the values in the given formula and you can calculate the values of acceleration produced and tension produced in the string. So this is a good question, students. Now We are moving towards the next question, that is the third numerical. Now, in this question, there is we have to calculate the normal reaction produced in the pulley also. So that is R is equal to 2T in case of pulley. Then here you can do is what 2 into 2 M1 M2 G upon M1 plus M2, and from here you can 4 M1 M2 G upon M1 plus M2. This is the normal reaction produced with the pulley. Now the third numerical strength. Yes, students, this is the next question, and in this question it is given that two bodies of masses 10 kg and 20 kg respectively kept on a smooth horizontal surface tied to the ends by a light string. The string has no mass. A horizontal force of 600 Newton is applied on A and B along the direction of the string. What is the tension in the string in each case? So suppose we are drawing, yes students, we are drawing, this is the case first, and when force is applied on block A, when force is applied on block A, simultaneously the forces are being applied on block A and block B. Suppose this is the smooth horizontal table, and on this smooth horizontal table we had kept the mass M1, and we had supposed this as A, and it is tied with a mass M2, and it is supposed as B, and a force is applied. Firstly, the force is applied on A, due to which the tension T, and the tension T is produced in this direction, and the whole system is being accelerated in this direction. So this is the first case, students. It is according to the question. We had drawn the diagram, masses M1 and M2. A, we had supposed mass M1, and B, we had supposed mass M2, and a force is applied on mass M1 due to which the tension T is produced. Now, drawing the free body diagram for this case for masses M1 and M2. So, F.B.D for M1, F.B.D for M1. Look at here. We had supposed mass M1. Since we are not going through the vertical direction, so we will not going to consider about the vertical forces. We only consider for the horizontal forces. And here, look at here, the force F is applied here for mass M1. Tension T is applied in this direction, and acceleration is in this direction. So force is M1 into A. Now, from this free body diagram, we will write an equation. The equation is what? Look at the equation. Since the body is accelerating in this direction, so we will write it as F minus T is equal to M1A. Since the body is accelerating in this direction, so the greater force is along this direction. So we had subtracted this force with the tensor T, and we had got F minus T is equal to M1A, and we had marked it as equation 1. Now dear students, there are another mass also in this system, that is FBD for M2. For force M2, we will draw the FBD, and for M2, suppose this is mass M2, this is mass M2, and the tension produced is in this direction. Tension produced in this direction, and the body is also accelerating in this direction. But body is also accelerating in this direction. So M2A. No net force is acting. Direct force is not, any direct force is not acting on mass M2. So we can write it as T is equal to M2A. Means you can write it as T minus M2A, that is equal to 0, and it is equal to T is equal to M2A. This is equation number 2. This is equation number 2. Now you may add these two equations. You may add these two equations, adding 1 and 2. Adding 1 and 2. On adding 1 and 2, what will get? T to T cancel it out, and F is equal to M1 plus M2 into F. So in case first, the net force is equal to F is equal to M1 plus M2 into A, and from here we can calculate the acceleration. A is equal to F upon M1 plus M2, and F upon M1 plus M2. So the force is of 600 Newton. 600 upon M1 plus M2. M1 it is given mass M1 and M2. It is not given in the question. So 10 plus 20. 10 plus 20. So it is equal to 10 plus 20. And this is the acceleration meter per second square. Meter per second square. So it will be A is equal to 600 upon 30 meter per second square, and into the 20, that is 20 meter per second square. This is the case for first case, that is the acceleration. Now if you have to find out the tension, so we had tension T is equal to M2. What is the value of M2? M2 is 20 into 20 Newton, and it is equal to 400. 20 into 20, that is equal to 400. Tension is equal to 400 Newton. Now the second case is when this force is applied on mass, and similarly you can find out when the force is applied on the block B. When force is applied on block B, then you can calculate. Look at here, I am solving in terms of when the force is applied on block B. When force is applied block. When force is applied on block, look at here students. This is M1, this is M2. Force is applied in this direction. So acceleration is in this direction. Acceleration is in this direction. So T acceleration A for body A is equal to M1 A, and for body B F minus T is equal to M2 A. And again adding equation 1 and 2, we get A equal to 20 meter per second. A is equal to 20 meter per second square, and T is equal to M1 into A, so it will be 10 into 20 Newton, that is 200 Newton. So tension from here we get the tension is equal to 200 Newton, and the previous case we had got the answer as 400 Newton. Now students, the last numerical we will discuss. Now dear students, look at here. There is a question on resolution of forces and F.B.D. Both are included here. You have to find out the tension T1 and T2 in the string. Tension T1 and T2 in the string. When a block of 4 kg weight is attached to the string as shown in the figure. So we have, look at here, in this question it is given, it is 60 degree, it is given as 60 degree. So these are the two horizontal lines and this is the transversal, so alternating degree angles are equal. So this 60 degree is equal to this 60 degree. Now resolving T1 into its two components, it will give T1 cos 60 degree and it will give T1 sin 60, T1 sin 60 degree. Now this weight is under equilibrium under the effect of these forces. So equating all the components. So first of all, we will discuss for vertical component of forces. Vertical component of forces. Vertical component of forces, and in vertical component of forces, T1 sin 60 degree is equal to 4 kg weight. That is equal to, you can write it 4 into 10, acceleration will be 4 into 10 Newton, and T1 is equal to 40 upon sin 60, and it is equal to sin 60 degree root 3 by 2, and it is equal to 80 root 3 Newton. Clear? And T2 is equal to T1 cos 60 degree. T2 is equal to T1 cos 60 degree, and you have find, so you can calculate. Now the value of T1 is 80 upon root 3 into half 40, that is equal to 40 upon root 3. This is the value of T2 is 40 upon root. This is the value of T2. So, dear students, these are the numericals. There is a numerical I am giving to you to solve yourself. Look at here. Suppose alpha and beta, these are T1 and T2, and this is of mass M1. This is the mass of mg. Mass and weight is at mg. So here you have to calculate the value of T1 is equal to what and T2 is equal to what. Do by yourself, student, this question. Consider a body of mass m suspended by two springs making angle alpha beta with the horizontal shown in figure. If the body is in equilibrium, find out the tension in the strings. You have to find the value of T1 and T2. This is numerical self. Do this numerical by yourself. Try to solve it. And that's all for today, students. Now, in the next video, that is on next video, we will start the next topic, that is friction. So that's all for today, students. Thank you. Have a nice day. Take care.